Hey guys, welcome back. In this video, I will mainly talk about how does channel affect the RF beam. Okay, so in the previous video, I was talking about how this pre-coding matrix would influence the RF beam. Okay, so I had taken the example matrix of this form, and I was mentioning that with this, the beam would be forming in these directions, right? So, but first of all, how did we get even this pre-coding matrix? So we had estimated the channel using some reference signal, and then H is decomposed, SVD decomposition was done, and we used to get U sigma VR emission, right? And this matrix V, we are using it as the matrix W or the pre-coding matrix at the transmitter side. Okay, so that's where we used this pre-coding matrix here. However, what was our intention? Why we were using like this? Basically, we wanted to nullify the effects of channel, and we need to ensure that at the receiver, the signals across the antenna are separated out. Okay, there shouldn't be any interference of the signal from one antenna with the other antenna. That was the goal, right? So once we are using the pre-coding matrix, we were expecting that some effects of channels are nullified, and then the receiver, if we are doing some more receive beamforming, then we are going to ensure that we are getting the separated signals out across the antenna. For example, um, let's say, okay, this is transmitter side. Okay, this is the receiver side. Now, the thing is that from the transmitter, we applied a precoding matrix, let's say V into X we applied, and from here, immediately right after the transmission, we are expecting that the beams are formed in this direction. Let's say for now, the rank is 2, and two beams are formed over the air, and they have got some different directions. Okay, so these directions are represented by this vectors v1 bar and v2 bar, the columns of this matrix V. Now the thing is that this, soon after we transmit this channel, okay, so this is like we are using V into X, right? So soon after, in this channel, which was U sigma VR mission, now we have transmitted Vx. So basically Vx will come over here. If you take this model, y is equal to hx plus n, right? So this x is now V into X. Let's say this is X tilde, so V into X. So now U sigma V emission Vx. So this V emission V is actually identity, right? So now we are left out. By the time it comes out, I mean, after the channel, at this point, at the receiver point, what we get here is just U sigma V, right? U sigma, sorry, X, which means that now the beams are in the direction of this vector, columns of the vector of matrix U. So at this point the beam would be in the different directions. Maybe okay, something like this. So they might be in different directions. So at the receiver end, we need to perform the receive beamforming, which is we need to apply U emission to this U sigma X. So U emission is identity, and finally we are left with the sigma X. The sigma X is a diagonal matrix, which means that the X1 and X2 are separated out across the antennas, and we are able to nullify the effects of the channel. So this is what we were doing, right? See, from year to year, if you clearly see, there is a change in the direction of the beam, or the beam characteristics have been changed. So basically, I want to explain like why or how this is getting changed. I have some visualization or idea, so I want to tell to all of you. Thing is that first we need to understand from the antennas when the beam is out. Let's say we are telling that the beam would be formed something like this, right, with some side lobes. Then I was explaining in the previous videos how we were able to form such a kind of beam, on what basis. So I was mentioning that the signal coming out of this antenna number one, let's say S1 of t, and this also, let's say S1 of t for now. Then the signal which is coming out of the antenna are undergoing constructive interference and as well as destructive interference. So wherever there is a constructive interference, the energy is seen and good energy is seen, and then the signal beam, I mean the signal is or the beam is formed, something like this. Wherever outside of this beam also signal is there, but there the signal have undergone the destructive interference, and the signal level is below the noise floor of the receiver. So that's what I was mentioning right now. When from the transmitter we are transmitting the signal in some direction, then in the channel what is happening, see, there could be, we have transmitted something like that, but there could be some buildings, right? There could be some buildings. So let me write it. So there could be some buildings, and okay, let's say this is a building, and there could be some reflectors. So signal would be reflecting, and there could be some we have scattering phenomena, reflectors, diffraction, all these things. So over the air, let's say the signal which is supposed to have constructive interference at this point in time, I mean at this part or at this place, because of reflection or something, this constructive interference might happen at a different point. Okay, let's say so the constructive interval, because this would travel some longer distance, let's say this is also traveling at this point, both of them might be of same phase, and the signal might have the constructive interference at a different direction. So basically, with a lot of reflection, scattering, and a lot of obstacles in the medium, in the wireless channel, the signal which is supposed to have the constructive interference in these regions, yeah, we it might happen at a different region. Maybe now with all these things, now the beam would don't know, the beam would form something like this. So that's why the channel would change the characteristics or change the direction of the beam when the signal passes through the channel. Okay, I hope you got this clarity. So that's why, in case of SVD, as we are seeing here, after nullifying the channel effects at the transmitter, we see that while receiving, we are seeing the beams in a different direction, and on those directions only, we have to perform the receive beamforming in order to get back our signal. Okay, since I had taken a rank 2 case, okay, so let's say a rank 2 case. Right now, what might happen is that so in case of rank 2, let's say both the layers are working fine for some duration, but now the let's say this is UV, the UV might have changed its position, or it was, let's say, traveling, or even, let's say, the channel environment itself has got changed. Then then it may so happen that the channel environment might have created such a way that the two beams which were forming in different directions, okay, let's say the beams which were traveling, which were formed in different directions, now with the channel conditions, okay, it can so happen that the two beams are almost overlapping. I mean to say they are parallel to each other, or they are formed in the same direction. That's why we can say that after some time, if the channel conditions are bad, we usually say it like that, right? The channel conditions are bad. In which case, if you see the H matrix, you will see that this is H11, H12. Even we will have the other column as well with some constant alpha into H11 and mm, some alpha into H12. Okay, we will have the same directions. If you see this, we have the same directions. So this is when the columns of this matrix H are dependent, and hence this is a rank 1 case. So it can so happen that the beams might be traveling in the same direction, in which case we can support only layer 1. Okay, So in such situations, whenever we are transmitting with, because I've taken a rank to case, right? So with some reference signal, maybe a DMRS, or let's say this is a pilot, right? Or with the SRS. Whenever we transmit the signal and at the receiver, if you notice that with this DMRS or SRS, after the channel estimation, if the rank is equal to 1, then from next moment onwards, we need to inform to this transmitter that so you have to transmit with the just rank 1 or layer 1, because the channel conditions have changed, and with the channel conditions we are seeing that both the beams are traveling in the same direction, and then there is only one direction along which you can transmit the signal. That's why you proceed with the rank 1. So that indication will be given to UV. I hope you got a clarity with respect to how the channel is going to affect the RF beam, how it is going to change the beam directions, or how it is going to change the characteristic of the beam. With this, I will wind up the video. Thank you very much. Have a great day. Please do subscribe to the channel. Bye bye.